Welcome everyone. I would like to express that we are very grateful for this interest in the topic and thank you for taking the time to join us for this webinar session today. My name is Katharina and I will moderate today's webinar with the subject Sustainable Fastener Surface Coatings for Challenging Construction Needs. First and foremost, I would like to introduce to you Dr. Regina Mertens and Pasquale Gozzolino, who are our speakers and subject experts today. Dr. Regina Mertens, Global Coordinator Alpha and Beta Sites Corrosion Protection, holds a PhD in Inorganic Chemistry from the University of Frankfurt. Back in 2011, Regina started as an application engineer at Atotech, focusing on corrosion-resistant coatings. Since 2016, she has been responsible for coordinating the alpha and beta sites in that field globally. 2018, she has extended her responsibilities coordinating the alpha and beta sites for zinc flake coatings. In the year 2020, she broadened her responsibilities to include the fastener sector for the construction business. She has been researching and analyzing the evolving needs for surface coatings for fasteners. And then we have our second speaker, Pasquale Gozzolino. In 1989, after completing his studies in chemical engineering, Pasquale Gozzolino, Tier 1 Manager Europe, began working in the surface treatment sector. After joining Atotech in 2001, he has held several positions and developed a broad technical background and market understanding, with a particular emphasis on the fastening sector. Following a lengthy career in product business and organization management, he has been working directly with fastener manufacturers, OEMs, and job platers as a Tier Manager Europe. Since 2018, he is now concentrating on the fastening industry supply chain. Additionally, in the last 5 years, Pasquale has begun working on fasteners for the construction industry. Since then, he has been researching and analyzing the shifting needs for surface coatings for fasteners. A couple of words about the webinar before we start. The webinar will be divided into two major parts. We have about 50 minutes presentation and 10 minutes Q&A session. I encourage you to raise questions during the presentation, and therefore please use the Q&A function, which you can find in your control panel. Keeping confidentiality, we will not publish the question, so you can only see the question that you posted into the section. We will try to cover as many questions as possible during the planned Q&A session at the end of the presentation. Of course, if time allows, we will answer all questions right away. Also, Regina and Pasquale will be available after the webinar to reach out to you via email. Last but not least, there will be a recording available after this webinar session, and we will let you know when it is released and send the link via email to you. So now let me hand over to Regina and Pasquale, and please enjoy the session.
Thank you, Katharina, for your kind introduction, and thank you to all of you for your interest and for the high participation today to our the webinar. Together with Regina, we will give an overview from our perspective, from the perspective of surface coating, of course, about what's happening in this moment in the construction industry, with a special focus on the fastener. And of course, which can be the possible solution, the sustainable solution, in order to fulfill this requirement. A brief overview on our agenda after a short introduction, also including the change on the market from market and technical scenario. We will talk a little bit about sustainability and carbon footprint, knowing how much this is a not topic today. And after that, Regina will help us to better orient in the technical standard specification requirement applied in this sector. We will move afterwards on the technical session, where we will introduce our sustainable system for corrosion protection, and we will talk about electroplating and about zinc flake application. Since with a unique approach, we are able to provide solution in both technologies. And going to the end of the presentation, before the summary, we will have just some brief information about our possible best local service, how we can interact on your market in the most efficient way for you. Now, let's start. First of all, when we initiated the project 5 years ago, the first point was, let's understand the special feature and complexity of construction industry. Is a quite special industry because, in particular, in terms of technical requirement, but we'll go later more on this aspect. And this was absolutely needed in order to deal with the changing requests in terms of coating properties, and as we already told, the increase in technical requirement. And how to, let's say, how to transform these change in the kind of opportunity also in order to introduce a product with a greener approach, and of course also with the cost effectiveness, knowing how much this is an important topic in our industry. So let's start from the change that we are having on the market, and I would like to start to talk about the influencing factor from the technical side. When I was talking about let's say the technical needs of your market, first of all, we should consider that the harmonization level of the technical requirement and the testing methods in construction industry, it's still, let's say, quite low. We are still quite far to have a very harmonized technical requirement. There is a lot of activity ongoing in order to improve this situation at the global level. Surely it will pass also through the release of new international technical standard for fastener. Here, just as example, we are mentioning two of them, two new standards. The first is the ISO 2702. This is connected with the heat-treated tapping screws, so it's closely connected with the construction application. And the second one, maybe even more important when we talk for surface coating, is the ISO 4042. This is a standard with a new release in June 2022, and is connected with electroplating coating system for fastener. So it means that it's touching in general the fastener application and of course also construction. Considering the importance of this standard, afterwards with Regina we will collect much more information on this. And last but not least, another important factor is also the increasing of a technical requirement in terms of corrosion resistance and friction behaviors. This is mainly due to the new application needs, and therefore you will need to find new solution to fulfill this requirement. When we move on the factor influencing from market point of view, of course the first one, and I imagine we don't have to spend too much word on this, is the cost increasing in terms of energy price, freight cost, and raw material cost. You know better than me what's happened in the last years after the pandemic time. And of course, now the situation for some aspect is going better, but we are still quite far from the original situation. And in some case, not only for this, but mainly for this, we could see also several cases of risk of a supply chain disruption around the globe, and with the following business regulation situation. On top of all this story, we cannot forget the sustainability topic and the carbon footprint reduction. Considering how much this point is important for our industry, but not only, also for our really daily life, we will spend some further word on this. First of all, telling that we could see a kind of a change in the last time. And here we use this word from theory to money. What does it mean? In the past, when we talk about sustainability, we are almost talking about some kind of philosophical concept. But the situation in the last years is changing a lot, is changing very fast. Now we are talking about money. It means that the sustainability, carbon footprint reduction, will be surely a strong game changer in already now, but even more in the coming years, and it will have also a strong impact on the economic side of the story. First of all, let's align on some basic concept. You know, but just to be on the same page, what does it mean carbon footprint? The carbon footprint is the amount of carbon dioxide, CO2 emission, associated with all the activity of a person or entity. Can be a company, can be a building or a country. usually are reported in tons of emission, so-called CO2 equivalent, per unit of comparison. Can be per year, per person, or, as in our case, why not, let's talk about carbon emission for kilo of screws produced. In this moment, we can see a high pressure at the global level on this topic. We can see a lot of activity atoms in order to create roadmap to achieve sustainable economies in the coming future. And just to make an example about this, let's talk about the European Green Deal program. This is a special program for Europe who has the target, the challenging target, we should admit, to achieve the reduction of greenhouse emission of 55% by 2030 and to be carbon neutral by 2050. So it's really a challenging target. And part of this program, we have CBAM, the so-called CBAM, that it means Carbon Border Adjustment Mechanism. At the end, this is a kind of carbon tariff on the carbon intensive product such as iron and steel, and it will have, let's say, the goal it will be applied on the imported good from extra Europe, and he will have the goal to force, let's say, the other country to follow the European regulation in some way and to use the most sustainable and greener technology. Because in case of extra carbon produced, a tariff will be paid based on this. So we are talking really about money in this case. But when we talk about carbon footprint, always one of the main problems is let's try to have some number. Unfortunately, a carbon meter is not yet existing, and therefore, to understand which is the real impact and real emission of carbon CO2 footprint, what is possible to do is to evaluate the entire value chain. In this case, we made a kind of experiment, let's say, working on the screw manufacturing. And we analyzed the single phase of the screw production process, starting from iron ore mining, moving to steel production. After that, we are in more, let's say, real fastener application, so with wire rod, cold forging and hardening. And we move afterwards to our parts. So we talk about plating and coating and with the related hydrogen embrittlement to arrive at the end to packaging and sorting. Of course, between a lot of these phases, we have a lot of transportation that anyhow should be considered. And also working very closely with our partner, we are able to estimate that the total carbon footprint for tons of screws is approximately between 1.5 and 4 tons of CO2. This range is strongly based on the different screw geometries, of course, on the steel source, on the energy source, etc., etc. But to give a clear number about the CO2 emission. And why it's important. This is important because only understanding where the CO2 emissions are coming from, we can act with our technology in order to try to reduce this carbon emission. Here we have just an example. We focus one step of our sequence process. It's the first one, it's the soap cleaner. And first of all, for your information, you should know that all your fastener, before to be plated or coated, we need clean it. We need to clean to remove oil and other soils from these parts. Usually, the soap cleaner step, it's operating with a very high temperature, 55, 80 degrees. So it means a lot of energy cost, as you can imagine. And on the other side, considering the big amount of oil usually present, you need to renew quite frequently. And we are working with our system, the Uniprep D315WL, exactly on these two aspects. The first is, let's try to have a product working with low temperature, and let's have a longer lifetime of the solution. And this product is able to do this, since we are working with 45, approximately around 45 degrees. And thanks to the natural degradation of the salts removed from the surface, you will have a much longer lifetime. So you will have much less new makeups. So what does it mean? It means less disposal. It means reduced chemical consumption, and it means, of course, cost saving. And of course, also we have a big saving in terms of wastewater. In parallel, as a direct effect of this, we will achieve also higher productivity, because having less maintenance stop to clean and to renew the tank, of course, we will have a longer productivity time. And at the end of the story, we will achieve also a more stable production with better cleaning quality. And to summarize, is also, of course, a big saving in terms of cost. This is just an example. This is just an example of what we can do. In this case, it's important to have in mind this number. And this is a quite precise number, of course, based in this case on the kind of line, on the kind of geometry, but we are able to save with our Uniprep approximately between 15 and 40% of CO2 related to the soap cleaner step. This is an example, as I told, but we are following a similar approach on all other step of our sequence process. Now, after this introduction, I will leave the floor to Regina, that she will give us an overview on the technical standard specification and requirement. Please, Regina.
So also hello from my side. And I would like to go with you into the world of specification, standards, and requirements. And here I would like to introduce to you the ISO 4042, which is a specification for electroplating coating systems. So for fasteners which have on top of the base material some zinc or zinc alloy layer, and then also being passivated and maybe have also additionally a sealer or a lubricant on top. This specification was completely revised last year, and also they are now telling inside the specification that the requirements which are mentioned in the document have precedence over all other documents dealing with electroplating fasteners. Why they are doing this now? So by the revision they did, somehow they implement also the best of other specifications. So for example, also commons, which was previously more in the ASTM standards, are also now here included into the ISO 4042. One very important chapter inside the specification is dealing also with internal hydrogen embrittlement and the measurements to how you can prevent this. This was also completely revised, and later on Pasquale will also give you some more information about. Other things which are in the specification are for sure connected with performance and performance requirements. Here just an example to mention the information there inside also about corrosion requirements and tests. So they are giving performance requirements for the neutral spot spray test, and they are also mentioning the Kessenich test, which is for outdoor building fasteners. Also for these two methods, I will give later on a little bit more information, as they are mainly used in construction. The next is the ISO 10683, which is somehow familiar and similar to the ISO 4042, but here it's dealing for zinc flake coated fasteners. Means when you have on top of your base material a base coat or a top coat on top. They are giving the hints that the coating you can use here also for high strength fasteners, because one really positive effect of applying zinc flake coatings on your fasteners is that there is no hydrogen generated, and so the risk of internal hydrogen embrittlement is avoided. They are also giving hints about the curing process that you need to have a little bit take care of, sorry, because this may affect your hardened and nitrocarbonate fasteners. Other information they are sharing is about chemical resistance. So for example, that organic top coats are much more resistant against acidic or alkaline chemicals compared to inorganic top coats. We know we have a quite mixed audience here today. So on my next slide, I would give some information about electroplating and zinc flake coatings just that every one of us is on a little bit on the same level. So both kind of systems, they are excellent in corrosion protections and also quite cost competitive. When you are looking into the electroplating coating system, means your zinc or zinc alloy layer, maybe passivated and sealer on top. When you are choosing this kind of application, you have the benefit that you can also treat small and difficult geometries. Also, by mixing a perfect match of passivate and sealer to each other, you can really fulfill a quite wide range of corrosion requirements. You can find the perfect solution to your specific requirement. The drying temperatures in case of electroplating are quite moderate, so you don't have here high curing temperatures, and all the systems are non-PFAS containing. The zinc flake coatings have also have excellent behaviors connected to friction. As mentioned in the ISO 10683, there is no hydrogen generated, so you have no problems with the internal hydrogen embrittlement. There are no rinses needed after this applying of these coating systems, so you have here no wastewater generated, and they are free of harmful heavy metals. And with our portfolio, we have here also the possibility to combine both worlds. So at the end, this is that what we are calling CP coatings. CP is standing for corrosion protection. So to have on top on your passivated zinc layer, for example, a top coat. With this combination, you can really achieve a high-end corrosion protection, especially with an outstanding corrosion protection connected to Kestenich test. We will also see there later on an example. The top coats are providing an excellent appearance. The temperature for the temperatures, they are quite stable. And as mentioned also in the ISO 10683, the high chemical resistance, especially of the organic top coats. And also the top coats are this layer system, which was providing really an excellent friction behavior. We now have our different fasteners coated with our different systems. And for sure, then it will be interesting to see how is the corrosion performance. And two main tests here are the NSST, which is described, for example, in the DIN EN ISO 9227 or in the ASTM B117, and as well the Kestenich test, which is the DIN EN ISO 22479. A little bit details about these two kind of corrosion tests you will see on the next slide. But here I would like to mention a comment out of the ISO 4042, which is giving the hint that these accelerated corrosion tests, which you can use, you cannot directly relate to the lifetime of your part. Means something which is surviving this and that hours in NSST, you cannot directly correlate that it will survive, for example, 5 years, 10 years, 20 years in a real life application. This is the reason why still you have a lot of outer corrosion tests running in construction. They have this possibility for the direct relation, but they need for sure several years till you have your result. The really benefit of having this accelerated corrosion test is that you can compare on a quite fast mode your different corrosion behaviors. So you get already after some hours, weeks, or a few months, depending on your corrosion requirement behind, an answer which solution is better in corrosion protection and which not. On the next slide, just a short overview about the two main used corrosion tests for construction. So in the NSST, there is a neutral salt solution which you are spraying on your test part. And then this test is running always under constant corrosive conditions. They will not be changed in between. And you are here evaluating the hours until your white corrosion, means your zinc or zinc alloys corrosion is starting. And additionally, also when the red corrosion is starting, means the base materials corrosion. The Kestenich test is a much more aggressive test. The reason for this is that they are also using sulfur dioxide inside, which is a pollution, one of the main pollutions in our atmospheres, especially in the industrial areas. The test is running in 24-hour cycles, and in these 24 hours, they are also changing the corrosive condition, means they are also changing humidity and temperature, for example, in between. Here, it will be typically evaluated the hours until an upfront agreed percentage of red corrosion will be visible on your test parts. With this, I will close my first session here and hand back to Pasquale.
Perfetto. Thank you, Regina. And let's move now to the second part of our webinar, where we will talk more in technical details about the sustainable use of a corrosion protective application. And here the first point is how to define the greenest solution, the most sustainable solution. The first point is, let's understand exactly which are the corrosion requirements. What I mean, we have different requirements for the respective place of use of your fastener. Of course, a fastener applied indoor is a completely different situation than the outdoor fastener. And based on this first analysis, we can move to the next phase. So let's identify the right solution to fulfill this specific requirement. And the next step, one more, is when we identify this solution, of course, this solution should also have some specific, let's say, criteria like reduced emission, efficient raw material utilization, waste weather reduction, and last but not least, of course, energy saving. We will focus now the attention on electroplating coating. After Regina introduction, all of you are experts of this, so let's jump directly to the next slide, where we will talk about the AZZINK solution. This is the easiest system, is very well known in construction industry, very well used. And in particular, we'll talk about AZZINK solution, but with the focus on the influence on the layer properties by using different post-treatment. Okay, first of all, we should consider that in construction industry, the requirement can have a very, very wide range. So we can start from some really basic, let's call basic requirement, as we can see in this example, to arrive to very high requirement. Talking about this example, this is coming from ISO 4042 that we will use as a reference once more, and this connect with the transparent and blue application. In this case, these parts have been plated with our system G-Lite in combination with the blue passivation Pastigal EM, and the idea is let's fulfill the entry-level requirement in this standard that we are talking about 8 hours for white corrosion and 48 hours for red rust corrosion with 5 micron of zinc and 96 hours with 12 micron of zinc. We can see the first row is the case with the lower thickness, 5-6 micron, and we can see that we don't have any presence of white rust at 8 hours, and at 48 hours we have W2. For your information, on the right side you find a legenda who is helping to understand this result. It is quite self-explicative. In any case, on this topic and all other topics that we are showing in this webinar today, in case you have you need more details or you have a special question, really don't hesitate to come back to us at the end of the seminar or also afterwards. Moving to the next row where we have 12-15 micron of zinc, we can see again no white rust at 8 hours, and at 120 hours we have only white corrosion with rating W4. But what's to do in case we need some other different properties, for example lubrication, or for example higher corrosion? Here we can see two different options. On the left side we have the friction additive family. In this case we are talking about pure lubrication. On the right side we have an example with our sealer 350 WL8. This is one lubricated sealer of our product portfolio, but we will use to explain the concept and the differences. When we stay on the lubricant, so it means on the left side of our slide, in this case we are talking about water organic wax emulsion, and they are able to adjust the friction properties, and it can be used by itself only with the water, okay, diluted with water, or can be also mixed with a no lubricated sealer. He can be applied on top of electroplating or zinc flake coating as well. and they are mainly used, for example, for self-tapping and wood screws. Here we are just mentioning two of our products, Friction Additive 9 and Friction Additive 10. And we want to highlight that these products are, all these products are not PFAS containing. We are telling this knowing how much the PFAS regulation in this moment a very big concern on the market. And with lubricant, we have always a very efficient cost solution. When we move on the right side, so let's talk about Sealer 350 WL8. In this case, this is a transparent sealer with integrated lubricant. We have a very good corrosion protection and very good scratch resistance. In addition to this, we have an advanced coverage power, but on the other side, we don't have excess fill on the complicated fastener. And you can see these screws, you have a quite deep internal head socket, and you don't have any issue with excess fill in this area. And also in this case, these products are not PFAS containing. Let's talk about some number. Always we prefer to use number to better explain this concept. Here we can see the influence of these two different products on the friction properties on the left, on the corrosion resistance on the right side. We can see that when we talk about friction properties, both systems are providing quite similar reduction of torque value. We are talking about 30–55% less when we are testing these parts according to the Wurth specification, the PA04400, and we are drilling in this case these screws in the beech wood. Different story is when we are on the corrosion resistant parts, because we can see that when we are on the friction additive product at 144 hours, we have W7 in terms of white corrosion, while we are moving on the sealed parts, we don't have any presence of white corrosion. We have just some black spot rated S5. Even more, moving at high requirement, 480 hours, on the lubricated parts, we see already some presence of red rust. We have R3, while on the sealed parts, we have only white corrosion. So we don't see any red rust. And the message at the end is, so in terms of lubrication, they are comparable. But when we need high corrosion resistance, the choice is to go, of course, on the lubricated sealed application. And this is absolutely needed when, for example, we move on the high requirement as the requirement in ISO 4042 for the iridescent sealed zinc layer with 8 microns, where we have been asked to provide 120 hours to white rust and 240 to red rust. So without this, really just a brief overview of the product portfolio available. We will not go in details, but you should know that we have in our dedicated product portfolio the lubricant, not lubricated sealer, and lubricated sealer able to fulfill your requirement, your expectation. So let's understand exactly what you need, and we are confident that together we can define the right solution for you. But what to do when we move on the higher, much higher corrosion requirement? In this case, it's helpful to introduce the AZ Zinc Nickel, and I will briefly show you the main difference between zinc and zinc nickel, starting from the corrosion resistance. Zinc nickel has a much higher corrosion resistance compared with the zinc. To give you some number, you can see this simple chart, where on the axis C, you have the micron of zinc or zinc nickel. On the ordinates, you have the number of hours of resistance to red rust. Just to, if, for example, we want to do, we can take the case of 8 microns, okay? In case of zinc, you have approximately 100–150 hours to red rust. When we move on zinc nickel, we are more than 800. So we have really a big jump. Big jump we can see also when we talk about hardness. And in this case, let's focus the attention on this graph on the two green column, it's zinc and nickel, and on the first one on the left, this is the typical AZ zinc application. Also in this case, we see that we are moving from approximately 50 beakers with zinc to almost 600 beakers with zinc and nickel. So it means 10, 12 times more. And we know when we talk about fastener how much important is the hardness of the surface when we talk about drilling or when we talk about the scratch resistance with the saw sharpened thread that usually we have in construction. Last point, but not less important, is the hydrogen embrittlement story. Regina gave you some hint about this, but let's talk exactly about the behavior of zinc and nickel. And once again, we use the ISO standard for this, the ISO 4042. And in the new release, it's clearly mentioned that alkaline zinc and nickel electroplating present a much lower risk of hydrogen embrittlement compared with the zinc. Therefore, it's possible to avoid baking. We want to be precise, and we should add that the decision anyhow to don't carry out the baking should be based on the testing, first of all, and be agreed between supplier and purchaser. This is mentioned for alkaline zinc and nickel. For the acid zinc and nickel electroplating, studies are showing exactly similar benefit, but of course, being a, let's say, less present solution on the market, more data are necessary to confirm that also in this case we can avoid the baking. The reason of this, don't be scared of this picture on the left side of the screen. In general terms, the main reason is the columnar texture of field-oriented crystal growing in zinc and nickel that give the permeability of this layer for the hydrogen. So the hydrogen can go out much easier. And here, just a very quick overview. Overview on our process Zinni 220 is our acid zinc and nickel electrolyte. One very important aspect here is the appearance. In this case, with acid zinc and nickel, and this is a big difference with alkaline zinc and nickel. With acid zinc and nickel, we can achieve a very bright appearance. The picture on the right side maybe can give you this feeling. You can see, in particular, on the picture on the bottom with the silver finish, it's not so far from stainless steel application. And we have a very homogeneous nickel incorporation and appearance, combined with a very good thickness distribution, also in the low current density area. And as we already show, we can have a very high corrosion protection when compared with acid zinc. Considering to close that this system is also boric acid free, we can consider this as the greenest and the most productivity zinc nickel technology currently available on the market. Some number to confirm what we are telling you. In this case, we are comparing zinc passivated parts on the left with acid zinc nickel parts on the right side. In both cases, only passivated. And you can see a big jump since we have at 120 hours with the zinc, we have W4, so it means we can see some white corrosion, while we have similar situation with the acid zinc nickel, but only at 1008 hours. And this is confirmed also by the second case, where we are comparing zinc and zinc nickel parts with the same post-treatment. In this case, we are talking about ECO3 HC22 is our passivation, in combination with the Sealer 350 WL8 that we already presented some slides ago. Here, the jump is even bigger because at 480 hours, only with the zinc, we can see presence of red rust in some case, while on the zinc nickel part, we don't have any red rust, but just some white rust presence at 1008 hours. So you can easily see that the jump in this case is coming from the zinc nickel deposit. After this brief overview on the electroplating technology, now I will leave again the floor to Regina, that she will talk about zinc flake system and our CP approach. Please, Regina.
Thanks, Pasquale. So let's go into the world of thin flake coatings. And before here going to our products, I would like to guide you a bit how these layer setups are really typically looking. We said all the time, okay, we have our base material, and on top of the base material, there we have a base coat, and then on top a top coat on top. But in reality, this application is done in several cycles. So as you can see here, it's always for sure starting with a pre-treatment, then the coating step is coming, then the curing step, the temperature depends on the process which is used, and then at the end there's a coating step. And then we need to go the cycles again, and this sometimes several times, because a typical layer setup contains normally 2 layers of base coat, and depending on the final requirement behind, 1 up to 3 layers of top coat. So you see, it could be at the end 4 or 5 cycles you need to go this process. We were for sure also looking, and on case on the base coats, we could find some really nice sustainable base coat solution which have already good performance just by using them with 1 layer. So here as an example, the Syntec 200 SLF, which is a base coat for the medium corrosion demands when you use it at 1 layer system, and this is already lubricated. Or when you have some higher corrosion demands, then we have the Syntec 1 HP available. What means medium or higher corrosion demands you will see also on the next slides. Let's start first with the Syntec 200 SLF. So this is a silver zinc flake base coat. It contains already a integrated lubricant. So you have directly, by applying this 1 layer of base coat, also directly some lubrication properties. And it has a very good coverage already after the first layer. That's the reason why you can use them directly after having just 1 layer on top. For sure, the benefit when you compare a 1-layer system to a 2-layer base coat system, you have a much higher efficiency. You can reduce your operating cost and the process time. And for sure, you also have just 1-time curing. So at the end, you have also here a lot of energy saving available. On the next slide, we will see some properties of this Syntec 200 SLF. On the left side, the corrosion resistance. So when you are using this top coat as 1 layer, you can achieve up to 360 hours. And you have directly some lubrication on top. And this means compared to a non-lubricated base coat, you have here a torque reduction of about 20%. If you need some higher corrosion and would like to have directly this lubricated base coat in use, then you need to go for a 2-layer system, and then you can achieve up to 720 hours. But as mentioned, we have for this higher requirement also another base coat solution available, which is the Syntec 1 HP. So when we have a look here in the details, so this is an inorganic base coat. It has not a lubricate directly integrated, so there you may need on top also some top coats like Syntec Top or others. We will see there also an example later on. As it can be used also as a 1-layer base coat, it has for sure as the Syntec 200 SLF the same benefits for higher efficiency and energy saving. Here on the next slide, you see the corrosion results you can really achieve with it. And keep in mind, this is just 1 layer of base coat with roughly 7 micrometers you have then on the screw. And we can achieve here directly 720 hours without any red rust. So you can fulfill the connected ISO requirement, the corrosion requirement of the ISO 106H3, which is for roughly 8 micrometer systems asking for 720 hours without red corrosion. And this we can fulfill just by having 1 layer. So this is really good. Here I would like to introduce also now to you the combination of this Syntec 1 HP in combination with our Syntec Top XTL, because this can provide you a nice 1+1 layer solution when you have some lubrication needs also additionally. So here really just 1 layer of your base coat and 1 layer of the top coat. Some words about the Syntec Top XT family. So it's the water-based clear inorganic top coat. And we have there also a version available which has an integrated lubricant inside. This is then the Syntec Top XTL. It has very good also corrosion properties, which we'll see then on the next slides. But first, some other benefits with this process. It's really easy in handling. It has quite low abrasion, a very good adhesion, and for a top coat, also a quite low current temperature of about 150 degrees with a range of 120 to 180. Here on this side, the really nice corrosion results you can achieve with it. On the left side, the combination in the zinc flake world, so with having Zintec 1HP plus Zintec Top XT, and with this just 1+1 layer solution, you can achieve up to 1000 hours without any red corrosion. By using it in combination with a CP solution, so having the Zintec Top XT on a passivated zinc nickel layer, for example, you can achieve above 1500 hours without any red corrosion. So really some really nice increasing of corrosion resistance you can achieve by using the Zintec Top XTL. As next, I would like to introduce to you two other top coats we have in our portfolio, which have some special properties which are very interesting for you. On the one hand, we have the Texil Brilliant Silver. It is an organic top coat, and organic top coats, as also mentioned in the ISO 10683, have a really nice chemical resistance. One benefit of this kind of top coat is its appearance. It's very attractive, bright and shiny silver. So really comparable to the appearance of a plate of an acid zinc screw, which you see it. So really nice shining appearance, which you can also see on the picture on the right side. For sure, it gives an additional corrosion protection when you are using this on top of a base coat or an electroplated finish. And it's also a non-PFAS-free containing system. Here are some corrosion results. So by using it on top of a base coat, you can also achieve 1000 hours without any red corrosion. The last top coat I would like to introduce today to you is the TechTip Silver SL. It's also an organic top coat, so high chemical resistance. And with this top coat, we have a perfect combination of very high friction, very good friction properties and high corrosion properties. So here on the right side, you can see the TechTip Silver SL. It has an integrated lubricant inside, and you can reduce here the torque value about 50% by using it on top of a just passivated screw or a screw which has just a non-lubricated base coat on top. So this is also already used in applications like for drilling into wood or for drilling through steel. You can also see on the pictures on the bottom on the right side that by drilling them into wood and drill them out again, there's also no significant flake off visible. Another benefit of this top coat is also the excellent corrosion resistant. So here, starting first with having a look on the NSST, so for the neutral salt spread test, independent if we use it on top of the Zintec 1HP, so in the zinc flake world, or if we are going in our CP world by using it on top of a passivated acid zinc layer, here as an example, we have no red rust after 1000 hours. I would like to highlight you also the Kesternich results. Here examples for 15 to 20 cycles, and you will see and you will say, hey, but I see there's some red corrosion on the pictures, and you are right, it's there. But as you may remember from my previous session, the Kesternich test is a very aggressive test. And due to this, it's very often allowed to have some upfront agreed percentage of red corrosion. So a typical requirements is are dealing with 5 to up to 15% of red rust when you are having 15 to 20 cycles inside the Kesternich. And this we are passing with both kind of applications, zinc flake and the CP application. But I would like to highlight here what you can see on the right side, the combination when you are using this as a CP solution, so on top here of a passivated acid zinc, where the amount of red rust is much reduced. With these examples, which were hopefully very interesting for you, I would now guide back to Pasquale. Thanks.
Thanks once again, Regina, for all this interesting information. And let's move now going to the end of our presentation today. But before to do this, we would like to share with you some information about our local service, our best local service. And when we talk about this, automatically we will introduce our tech center approach and our tech center network. Since we are fully convinced that it is one of the main pillars of our local service, we are providing this customer support in more than 40 countries around the globe with 15 tech centers. And why it's so can be so interesting for you this, because which are the main benefits for you? You should know that in this tech center we are running a pilot line for production with electroplating system and with zinc flake system. And thanks to this, we are able to provide you sample coating and sample plating even in bigger scale. Imagine how much can be helpful to do that in case, for example, of a prototype work or in case of a qualification of new parts. And in addition to this, having also material science and chemical lab there, we can provide also testing for you, for example, different kind of corrosion test or friction test, just an example. Of course, we are using a lot our tech center also to support our R&D teams around the globe. And the idea is let's use this line in order to stress and to test our new product before to introduce this product on the market. We are talking, you can see on the left side, there is a one line in Berlin. We are talking a very representative line. So also the conditions are very similar to the real condition that after that you will achieve on the industrial plating line. And last but not least, let's mention also the possibility of the technical training that we can provide with our tech center. And in this specific case, we can do the theoretical part, but also the handling part. So the concept is also to give you the possibility to touch with your hands, to plate with your hand your parts in order to better understand how it works and which are the, let's say, the behavior of these parts after the plating. Moving now, really at the end, we are on the last slide of our presentation, and we would like to summarize telling that it's evident in this moment that something is changing in the construction industry. We can see a lot of change from market and the technical scenario. On top of this, we see that a lot of requirements are highly increasing, and there is a strong request to fulfill this requirement, reducing the carbon footprint, and on the other side, to taking care of sustainable development. Hopefully, we were able to show you in this short time that a dedicated product portfolio is existing with electroplating and zinc flake anti-corrosion technology. In both cases, we are able to provide high performance, sustainable, and of course, last but not least, a cost-effective system. So hopefully you learn something more about us today, about our product, and not only, also in general terms about what's happening in this moment on the market. And now just come back